So now our next two ellipse questions, examples, we're going to go ahead and write some equations and find some information. So first one says, write the equation of the ellipse with covertices 5, 1, and 11, 1, and a major axis of length 10. So remember the equation of our ellipse. We need to think about x minus h squared over something plus y minus k squared over something equals 1. And then we'll have to determine which one is a squared and which one is b squared. Now, if you can visualize these points and think about the information they tell you without graphing, that's great, and go for it. I am more of a visual person. I'd rather see what these look like to help me find A and B in the center and all that. So I'm going to plot these points. So first I have a co-vertex at 5, 1. So 1, 2, 3, 4, 5, 1. And then I have another one out there at 11, 1. So 6, 7, 8, 9, 10. Running out of room, 11, 1. So these are my co-vertices. This helps me figure out a few things. First off, it's going to help me find the center because the center should be directly between our co-vertices. The second thing is it's going to help me to figure out the orientation of my ellipse. Remember, the co-vertices connect with the minor axis, which means the major axis must be the opposite direction. So I'm seeing this ellipse as more of a vertical ellipse, something like that, without knowing any numbers, where the co-vertices are showing the short direction, and then the vertices would be at the other end showing the long direction. Okay, so the orientation of this ellipse is a vertical one, which means my a squared should be paired up with my y, and then the b squared would be with the x. All right, so let's go ahead and find that center. If I have one co-vertex at 5, 1 and another one at 11, 1, the center should be directly between those two things. Definitely has a y value of 1, and the x value is the midpoint there. So if you can't calculate it, then go ahead and just think about 5 plus 11, divide by 2, and you've got your midpoint. So that would be 8, 1 as my center. Knowing that that center point is at 8, 1, I can now count out the b. So the b would be, again, representing the distance from the center to a co-vertex. That guy right there is b. And if the center's at 8, 1 and I need to move to 11, 1, b must be 3. All right, so that's just information from the co-vertices. So now the only thing we're missing is our a value. That's where our second piece of information given is going to come in. So the major axis, which would be in this case the vertical one, from top to bottom is our major axis. That's a length 10. Now major axis would include an A going up and an A value heading down. So remember, major axis is always a length of 2A. So if 2A is 10, then that tells us that A is 5. Okay, so anytime you're given a major axis, that's 2A. If I had given you the length of a minor axis, that would have been 2B. But I think we have everything we need for our equation. So let's go ahead and go back to our equation. Our center is at 8, 1, so I can make this x minus 8 squared and y minus 1 squared equals 1. And then putting in the denominators, b squared was the minor axis, and that was 9 because b was 3. A squared was our major axis. A is 5, so that must be a 25. Okay, so again, I needed to draw a little sketch to find those numbers. If you can do it without the sketch, that's totally fine, but don't feel any shame if you need to draw that just to see it. All right, let's move on to the next problem. This next problem is a lot like the problem we did with circles, where I gave you kind of a general equation, and we had to get it in standard form so that we could find the center and the radius. So this process is going to be very similar. We need to do some completing the squares so that this equation actually looks like the equation of an ellipse. So we're going to start out the same way. Let's go ahead and do some rearranging. So I want to make sure my x's are grouped together. So 4x squared minus 40x. And then my y's, so y squared plus 4y. And any constants like this plus 100, I'm going to go ahead and get to the other side of the equation. Okay, so sometimes these will be out of order. You just want to regroup x's and then y's and then equals your constants. So now with circles, we went ahead and completed the square for x and y. This one's a little different because this ellipse has a leading coefficient for the x. Now, if you remember back to completing the square, you can't complete a square when there is a leading coefficient. So if we were able to just divide out this number from everything, I'd do it and say, get rid of it. But if I chose to divide out that 4, that means my y squared is kind of messed up because it's going to be divided by 4, and I don't like that. So instead of dividing it out, what we're going to do is factor it out, but only of those x's. Okay, this will not affect the y's at all. I'm only factoring 4 out of the x terms. Then if there were a different coefficient for y squared, I would factor it out of only the y values. So we can kind of treat these separately. Okay, so 4 is factored out of the x's. Notice I left myself a little space that I'm going to fill in. I don't have a coefficient to divide out of the y, so I'm going to leave them alone, but I'm going to leave myself a little space, and then equals negative 100. So now I can go back and complete my square. So in looking at the x's, I can cut the b in half, so negative 10 divided by 2, and then square it. Should give me a 25. But the thing is, I didn't just add 25 to my equation. That 4 out front, if I had redistributed it, means I just added 100 to my equation. Okay, so don't just put a 25 on that right side because you added 25. If there's a number that was factored out, you've got to multiply those back together and adjust the right side of the equation by that value. Okay, so that's the tricky thing here a little bit with your ellipses. So consider that factored out value. The y's, we didn't really have to worry about doing that because there was nothing in front. So let's just complete our square. So 4 divided by 2 is 2. Square that makes 4. Again, there was nothing to multiply it with, so I get to leave that as a 4. And then we can go ahead and do our factoring. Leaving that 4 out front, x squared minus 10x plus 25 makes x minus 5 squared. Y squared plus 4y plus 4 makes y plus 2 squared. And then the constants at the right just make a 4. So with a circle, we were done at this point, and we could see our center and radius. But remember, the ellipse equation is a little different. The big thing is I need 2 sets of fractions. I need to know what a and b are, and right now I don't see that. And I don't see that because the ellipse equation always equals 1, and this one does not right now. I need to force this equation to equal 1. I'm going to do that by dividing out that 4. So every single term will get divided by 4. And then you can see, hey, not only will this equal 1, but we've got some fractions hanging out just like we want. So first fraction for the x's, look, those 4's are going to just cancel out. So I'm going to go ahead and write this as x minus 5 squared over 1 because I like to see that denominator. Second one for the y's is actually in pretty good shape, nothing to cancel. So y plus 2 squared over 4, and then there's the equal 1. So now this looks like the equation of ellipse that we can find all the information for. And actually, I'm going to add something in here. We're actually going to find the co-vertices too. I should have included that. Okay, so we have our equation. Let's start with the center. So center would be our HK coming out of the numerator. Looks like it's at 5, negative 2. Okay, vertices, we need to know what A is. Remember, a squared is our bigger denominator. In this case, that's 4, which means a is 2. And because that bigger denominator is paired up with our y, this is a vertical ellipse. So to find the vertices, I'm going to take my a value of 2 and put it with the y. So if we move up 2, we're at 5, 0. If we move down 2, we're at 5, negative 4. Notice the x value isn't changing because we're moving vertically for those vertices. B squared is 1, which means that b is also 1. And because b is paired with the x, I'm going to move horizontally to find the co-vertices. So horizontally from that center point, one right would be 6, negative 2. One left would be 4, negative 2. Okay, so we can see that distance of 1 showing up in the x values only. And then the last thing I want to do is find the foci. Now to find our foci, we need to know what c is. So c squared, remember, is a squared minus b squared. So 4 minus 1 looks like that's 3, which means c must be the square root of 3. Okay, and remember the foci always line up with the with the vertices. And in this case, that was vertical. So let's put the square root of 3 with our y value to find those foci. So foci would be 5, and then -2 plus or minus square root 3. So that takes square root of 3 up and square root of 3 down for those foci. Okay, now I'm going to go ahead and sketch my ellipse. If you need to sketch your ellipse as you're working through the problem so you can find the points, go for it. You do what you need to do. Okay? So if me adding and subtracting to the x's or the y's doesn't really make sense without seeing it, then draw as you go. Totally fine. Okay, so center, 5, -2. 5, -2. There's the center of our ellipse. Vertices were moved 2 up and 2 down. So we went to 5, 0, and 5, -4. Those are our vertices. Co-vertices went 1 to the right, 1 to the left. So 6, -2, and 4, -2 for our co-vertices. And you can see this is just a tiny little ellipse there. It's almost circular, tiny little ellipse. And then we could plot the foci in there if you wanted to. So that is how you take the general form of an ellipse and convert it to standard.